Hey guys, if there's one thing I can teach you in this life, is whatever you do, do the best you can, give 110%. This is me. If this helps one student, I'll do it. So, we got people still struggling with equations, and if I go fast, it's because I don't have time. Okay, so step 1, distributive property. Do any combining of like terms. And then 3, solve sequence. Okay, this pen's done. See ya. Alright. So, distributive property first. People still do 5 minus 4 and get 1. You can't do anything with that 5. What's the number one mistake made here? A negative times a negative. It's a positive. Alright, distributive property. Check 2, combining of like terms. I can't give you any extra credit for doing this, but maybe you'll watch it. It might help you. Alright, solve sequence. Trying to get x by itself. This is all integer work. If you don't know your integers, this can be tough for you. So different signs, subtract. Okay, what undoes multiplying by -4? You have to do the exact opposite of multiplying by -4, or undo it with division. We've been solving equations now going on 8 weeks. Okay, so the way I normally teach this, kids don't understand it. So I don't watch YouTube videos because I don't know what I'm doing. I watch YouTube videos to see, is there an alternate way to teach it than the way I've taught it for 20 years. So I saw this one thing where if you don't understand that when you do 5 divided by 5 it cancels, you can multiply both sides by 5, and it's like there's parentheses on that top part. I don't recommend this way because it's just going to give us 3x minus 8. But if you want to do it, 5 times 3x, that's 15x. 5 times -8 is -40. And then multiplying fractions, do 1 times 5. Okay, you're like, wait, there's still a fraction. No, there's not. If you would just understand that you can do 5 divided by 5 and cross that out, see, we get, okay, where was this earlier? Okay, so look at all that work, extra work we had to do, okay? When I multiplied by that 5, okay, if I'd have just divided by 5 and, just crossed out the 5s, look at how much time I would have saved. Look at all that. You would have saved 2 steps. Okay, so when you see this and you go, when you do that, okay, there's something called simplifying before, so we're multiplying these. So look for a numerator and denominator. All 5 will go into 5 once. If you undo division with multiplication first, okay, it leaves you just at 3x minus 8. And now, okay, so I'm thinking ahead to the next question. Once you get it here, you should be an autopilot by now, or I hope you are. Probably not if you've been struggling with equations. Okay, now, out of all the questions you had, this one is the most, let's call it, scariest one, because you got fractions galore. So you got a fraction here. You're like, okay, so you've taught us to multiply, everything by 2. But step 1 in all equations is, can you do the distributive property? Can you combine like terms? You got to do those 2 things before you can solve it. So, okay, remember, there's an invisible 1 between that negative 1. So that means negative 1 times those. Okay, so don't panic about the fractions just yet. Okay. You're really doing negative 1 over 1 times these items. So here, you get minus 5 over 2. And then minus times there's an invisible 1 there. So a negative times a negative is a positive. Okay. I put the subtraction sign kind of up there. So now we have this. Is once two denominators. I'll put a plus sign there if that makes you happy. Okay. So when you're adding fractions, once the denominator is the same, you just do the operation up there. Okay, why does this make every student uncomfortable? Well, you're like, the answer can't be 0. Okay, you're going to be shocked when you get into higher levels of math. How many answers are just straight up 0? It would blow you away. So, like, don't let the fractions intimidate you. Just remember, you've been doing fractions since 6th grade, and you can do them. Okay, so here we go. That's a negative 5 on the outside. That's a negative 4 on the inside. And that M being on the right side threw a lot of kids off. I remember grading these. Alabama didn't have a game, so I didn't watch a lot of college football this weekend. Okay, so 3M. Negative 5 times M is negative 5M. Okay, number 1 mistake time. Negative times negative. Negative times negative. Positive. Okay, don't start solving yet. You're going to get yourself into a world of trouble. Okay, 3 plus negative 5. Some of y'all, if you could get your energy rules down, you'd be so much more successful. So here's 0. We go right 3. Okay, I'm going to go back 5. Okay, so I went down into the negatives. How far into the negatives did I go? Well, there's negative 1. There's negative 2. So when you combine 3 and negative 5, okay, you got to subtract them. And then you had more negatives. Okay, now, this is where my rule of thumb kind of worked against some people. Because there is an invisible 1 in front of that, so you got to go minus 1M. Now, remember what we had over here, okay? We treat 0 like any other value. So if I do 1M and I subtract 1M, the reason I can cross it out is it gives me 0. Okay, if you don't like this way, since this is an instructional video, I'll show you a different one. When you divide by a negative, flip it. Okay, let me do a different color. So over here on the right, I'm going to break off here, and I'm going to show you what else you could have done. Okay, the way equations work, it doesn't matter as long as you do the same thing to both sides. I don't draw the river anymore because it messes up the inequality symbol. So over here you could go plus 2M. Now, I'm very particular about how I like my answer. That is an acceptable answer, but to me, that variable should be on the left. So I got to flip that sign because M's smaller. Okay, moving along. That's really going to mess up. Okay, all right. Just let it go. Frozen. Let it go. All right, here we go. So let's keep the variable on the left. That's always been my thing with inequalities. Okay, now a lot of kids think you flip it now. Okay, no. When you subtract, no flipping is required. Okay, so like here, you go left 3 on the number line, you go left 2 more, you end up at -5 on the number line. So same sign, add and keep. It's about time for a flip-a-roo. Okay, see, now when you divide by a negative, that's when you flip it. Okay, and I've tried to show y'all many times why -1 over -5 is 1/5. Well, it means -1 times 1. You factor out a -1. So -1 times 5. See, if I factor out that negative, anything divided by itself is a +1. So that's how you know. Okay, so the number of people that flipped it, or multiplied by -5, the number of people that did that was a lot. Okay, but there's something special going on here. Okay, that would have required no flip for you. Okay, 10x is divided by, you can do that division. So that's really what we're doing there. And I'll just put that plus sign in there so you know we're adding and subtracting now. Okay, you see that's divisible by 2, or 5, and that one's divisible by 5. So there would have been no reason to multiply both sides by -5. That flip will happen later. I've got, right now before my homeroom gets here, kids start showing up about 7:15 for my first period. So I got about 3 minutes. Okay, let's say you solved it a different way and you got partial credit. Okay, so people were like, I'm going to multiply by -5. Okay, the only thing you forgot about that situation is when you multiply or divide by a negative, you got to flip it. Okay, we'll flip it later over here. See, -5 divided by -5, it's still required a flip. Okay, so I'm going to put that aside for a second and do the easy way. If you've been doing your Math Excel, you get fraction answers like this. So anything that's on Math Excel is free game. Maybe I could make like a survey. Which problem are you struggling with the most? Because I could go over them in class. Okay, there we go. Negative over negative, positive. Okay, let's go with this person. Look at these ginormous numbers you're working with. Since I'm running low on time, I'm going to do... I always liked the shortcuts as a kid. So we got 85x. This is the only problem with you not noticing that you could have divided, is you're dealing with these giant numbers. Okay, now, both of these aren't even, so I understand why you struggled simplifying them. Okay, but our answer, remember, was 12/17. If it ends in a 5 and a 0, 5 can go into it. So since I already know the answer is 12/17, okay, I can guess that goes in 12 times, and 85 has to go into 5/17. And if you got a calculator out and, double check me, you'd get it right. So then, okay, maybe I got time for one more. Okay, graphing. Wow. Okay. So here you had options. Okay, we made it where you could get it in slope intercept for once. So you could have done it this way. This doesn't always work. Okay, you got to identify when you're in point slope. So we got lucky there. We know M and B. Okay, and then here I'm going to try to make point slope make sense to you. So here's point slope. M, x minus x1 plus y1. Because if I put that y minus y1 that was over here on the right side, it's the same. So here you could have done b is -1, m is m was 2 over 1. Always make, so this is y, this is mx plus b, slope-intercept. Okay, but to graph a line, all you need is the rate of change and one singular point. Okay, so we could have used point opposite. So what would make that inside negative? 0. Well, do the opposite of -3, 3, 5. So in the times when you can't get m and b on it, it gives you a starting point. Now watch what happens here. Go right 3, up 5. Okay, what was b? B was -1. I'm going to switch colors. Okay, so if it's in point slope, from there we'd go up to right 1. Okay, watch what happens if I come down here. Let's say I grab B first. Watch what happens. Up to right 1. Up to right 1. Oh, there's that point. Oh, so point slope might be making sense to you now. We could either start there, or we could start here at B on times when we can find when B's actually on the graph. That's why it's important to know point slopes. And we just learned another reason is it helps you with absolute value. Now this isn't absolute value. Okay, those would have to be straight grouping symbols. So here's my ruler. Okay, that's all I could get for right now. Okay, I'm willing to do anything to try to help your student, and if they want to know exactly what they did wrong, that's why I'm making this for them. There's a lot of different forms of slope-intercept, which that's really what confuses them, I think. And now we've added absolute value, now we've got inequalities. Okay, an inequality. Okay, I don't have a lot of time to make this video, so I'm going to go over how to do the problem. This is slope-intercept. B is your beginning point. Let me check my resolution because I feel like I'm not on a good resolution. Now I'm on the best I can do. It's kind of blurry. Maybe I can make it sharper. Yeah, that's way better. Okay, B is -1. So that's your beginning point. When x is 0, y is -1. Okay, changing y, we're changing x. Down 5, right 3. We're up 5, left 3. Get my handy dandy ruler. Okay, so this is a dash line because nothing on this line can work, and then shade below. Okay, when I tell them about shading, we're saying none of these ordered pairs work. When I talk to them about shading, I want them to okay, shrink yourself down and stand on this line. Well, you couldn't stand underneath it, you'd fall off. So you're standing up here. Okay, so it's like they're standing like this. Okay, or you're standing like that. Okay, what's above you? Well, above me, that's greater than. Okay, less than would be down here. Okay, because it's underneath the line. So, let me get my highlighter, and then you just highlight it. The slope-intercept, y'all know how to do that. Y'all got that. We're saying any of these values, it has an infinite set of ordered pairs. So all those in the shaded zone, we plug them in for x and y. Okay, I think what's really messed the kids up is we've told them about finding x and y intercepts for questions like number 9. Okay, and really, What they could do is, hey, let's get it in slope-intercept form. So how do I do that? Okay, you might ask yourself, well, the slope's not positive 3. I have to get a 0 sitting where negative 3x is. Because if I get 0 plus y, I don't have to write it. A lot of kids want to put negative 12x. They want to put those two together. But the reason we talk about like terms is at this very moment, x and a constant, those can't go together. Now, what can you read from that? Well, there's b. When you plug 0 into the function, okay, the y value is negative 9. So that's why the b works. So go to it's called the y-intercept. Okay, now the slope was negative 3 over 1. You're like, I can't go down 3, right 1. Okay, so you have to do the opposite. Okay? You could do 3 over negative 1, and it's still negative. So go up 3, left 1. Up 3, left 1. Once we draw a line through it, you'll see why the slope is negative 3. You don't have to worry about shading and all that. This is a solid line. Okay, I tried to teach them an acronym called HOIVUX. And it's a way I help kids remember how to graph these. Okay, so why is it a vertical line? Well, let's go to a table, and I'll show you why. When it says x equals negative 5, all these ordered pairs, nothing can be. Let's go negative 6. Okay. So why is it a vertical line? Why exactly is that? Because every single x coordinate on this line is negative 5. It's limiting us to what we can. So if I go negative 5, negative 6, and I go negative 5, 0, and I go negative 5, 6, okay, every single one of those x coordinates, like we could go for days there. Okay, it makes a vertical line. So the acronym I came up with, or I didn't come up with it, vertical line has undefined slope, and it has an x equal equation. So x equals negative 5. Okay, the other one we do is I taught them HOI. Okay, why exactly is this one going to be a horizontal line? Well, we have a boundary line. Couple things, okay, this means solid, and we're going to shade below. So that deals with the shading and stuff. But the boundary line we're really graphing is y equals negative 3. Why is it a horizontal line? Okay, well, let's look at a table of values. We can always go to the table, and it's telling us the only thing y can be is negative 3. So I'm just going to make up some random. See, it's got a y-intercept. I'm just going to make up some random points. So left 2, down 3, down 3, 2, negative 3. Okay? So horizontal lines have 0 slope and a y equal equation. So how do I know that's not slope? Well, there's no x on it. So it's really y equals 0x plus b. So it's really telling us, hey, b is negative 3. Okay, now you go solid, because any number on this line would make a true inequality. And again, have them stand on the line. What's above you and what's below you? Well, above you is greater than or equal to. Less than or equal to would be below you. Okay, so the second you see x is greater than 2, it's a vertical line where it hits the x-axis. It has an x-intercept at 2, 0. X-intercept is where y is 0. Okay, and this means dash. And greater than for this kind would be dash right. So I'm going to go dash. For like 1,000 years, or when I was a kid, they made me test 0, 0 on which way to shade. Well, if I look at that x value, okay, 0 is not greater than 2, so I wouldn't go towards 0. Greater than's this way, less than's that way. We can't really draw them standing on that line, so I don't know above or below them. Okay, now we're getting into where I saw a lot of ones. It's rewriting linear. So what is slope-intercept, you ask yourself? Y's alone. So we got to solve for y. Negative 2x and 9 can't go together, and the x terms first in slope-intercept. Divide by negative 3. This was on the Math Excel. So that's all they needed to do to get. So they got 2 points for that one. Okay, how do I get this in slope-intercept? We've been pushing point slope pretty a lot because it's helped us when we graphed absolute value functions. Is point slope is technically linear, doesn't really have a vertex, but it has a vertex form, and it's really point slope even though there's no vertex. Okay, so all you had to do, distribute that across. And then to get y alone, I just add 7. Okay, 15. We talked like in 3 days of the aims. Every day we talked about looking at ordered pairs and seeing if they were part of that inequality. Okay, the y's have to be less than negative 7. So you're not concerned with x at all. So I'm going to take a pencil. When it's talking about the range like this, okay, the x is irrelevant. The x coordinate has no bearing on the y one. Okay, and they were supposed to show evidence. Okay, so this tells me y is negative 7. So if I put negative 7 in the inequality that's given up here in yellow, hey, that's not true. Negative 7 is not less than negative 7. It's equal. So, no, not a solution point. Because that's false. Okay, this is telling me y is negative 5. If I put it in for y. Okay, a lot of kids think it is smaller. Negatives are different. So if I draw a number line, here's 0. Okay, so if I plot these on the number line, negative 5 is closer to good old 0. The closer you get to 0, the bigger it is. So this is yet another false statement. So that can't be a solution point. Okay, y is negative 12. Put it in the original inequality. Hey, we got our first true statement. True. So that point would definitely be in the solution set. Okay, negative 15 over 2. Well, how do you change negative 15 into 15? Just act like it's positive. Put 15 on the inside. 2 goes into 15 7 times. And the remainder is 1. So 7.5. Well, it's negative, so just put the negative on it. Treat it like a positive, put negative on it. Hey, we got another true statement here. Negative 7.5 is further from 0, so it's smaller. Okay, we've been trying to, this has been the focus of this week's aims. And, okay, so here's the function. I've tried everything I can to explain this. Okay, when it says f of 1, it's telling you x is 1. Okay, so that means in the function, you put a parentheses. Okay, we are putting 1 in for x. Okay. So you guys aren't on Facebook, but all the time I see these posts where they say, use the order of operation to solve this problem. And I go to the comments, and some people know it, some people don't. So, when's the last time probably an adult did this? Probably not a lot, not recently. But, okay. So, the order of operation tells me I have to do parentheses first. PEMDAS. Or also like BEDMAS. So, all we do is do 1/2 times 1 minus 5, which is negative 4. Okay, now we have to do multiplying. Fractions are not awful. Multiply across. Why do I keep putting f of 1? It's because I'm keeping it separate. We want to know what the output when the input's 1. I might have to finish this video in the morning. I'm running out of steam here. Okay, f of 5. Same problem. Okay, I'm switching colors because I get bored with the same old colors. Alright, this time we're putting 5 in for x. Yay, 0. 0 is the greatest number ever in these kind of problems. I'm going to go back and do my f of 5 later. Alright, 5 minus 5 is 0. Why'd I write it again? Okay, 0 plus 3, 3. So when x is 5, x is 3. I mean, y is 3. I'm getting tongue-tied here. Sometimes I wonder why my throat hurts. It's because I'm making all these videos just to try to help any way I can. Alright, here we go. Same thing. What are we going to put in for x this time? You guessed it. Negative 1. Okay, if you don't want to write f of negative 1, you can just do it at the end like I did. It's negative 6 over 1. This is the only one that should have tripped you up a little bit. Okay, what are we putting in for x this time? You guessed it. 0. Oh no, we're going to have to deal with decimals. It's not that bad. Seriously. 0 minus 5 is negative 5. That's a 1. Yeah. Okay. Negative 5 divided by 2 plus 3. Okay. Treat it like it's a positive. 5 goes in top. Alright. Y'all all know how to do this algorithm. You did it for hopefully forever in elementary school. Okay, oh no, it's negative. Okay, just put the negative on it. Then the calculator section started. Find the rate of change. How many weeks? We've been doing this for a while now. Okay. Mr. Slope Guy. Hello, Mr. Slope Guy. Positive. Negative. Undefined. 0. Mr. Slope Guy. We've been drawing him for a while now, and it tells you, oh, hey, as I go left or right, this one's negative. Okay, so this is 1, 2, 3. To me, I wouldn't use the calculator on this section, but that's just me. On this page. Okay, the number one wrong answer here was 10 over 3. Okay, so how do we find slope? Well, we fall down. 1, 2, 3, 4, 5. Let me count negative. Negative 6, negative 7, negative 8, negative 9, negative 10. So the change in y was, it went down 9. Okay, it went down 10. So A rock. Change in y over x. Change in y, negative 10. Okay, 1, 2, 3, 4, 5, 6. Change in x, 6. They're even numbers. Okay, it's always got to be simplified. Okay, let me see if I can. Let me get the calculator up. I'm gonna pause it, and just like magic, there's the calculator. It's not magic. Magic. Sorry. How could I have had my calculator simplify that for me? Well, negative 10, alpha y equals, enter, 6, I press enter. Oh, okay. Or you could just half it. Okay, you have to know point slope. Or let's write it, now that we know vertex form, let's take that y1 to the other side. I'm one of these people, I like that minus y1 on the left. That's how I roll. But if you want to bring that plus y1 over, actually I don't like that way. I prefer this way. Okay, which ordered pair do I pick? Doesn't matter. Which one could have got you the slope intercept faster? The bottom one, but okay. So this is x1, y1. In the formula, there's a minus sign in front of y1. So that means the opposite of y1 is 5. Slope. Okay, that means opposite x1. Oh, x1 was 3. What's the opposite? Well, that's a negative 3. Or if you wanted to write it in this this point slope where you take y1 over there, so it looks like vertex form. Let's take a look at what that would look like and see if you prefer that. X minus 3, and this time, if the y1's on the right side, it's the same sign. Okay. So Okay, some kids aren't good at seeing the change. That went down 6, up 4. That went down 12, up 8. Negative 3 halves again. Check it one more time. Down 3, up 2. Boom. A-rock, negative 3 halves. Okay. Which ordered pair do you pick? Dealer's choice. X1, Y1. Hello. Alright, let's do it this way. Let's try it that way instead. M, negative 3 halves. Opposite of X1. Opposite of X1. Minus 1. Alright. Y1 stays the same if it's on that side. Or you could have done Y plus 3. I would have accepted either answer. Last questions. Okay, IL. Man, I'm running out of... Okay, I got this. Alright. All week, we put stuff in the calculator. And a lot of days, 10 minutes in, some people didn't even have the lid off the calculator. You could have used it. Okay, how do I put a fraction in? Alpha y equals. Enter. 5 down 2. Oops. Parentheses. I couldn't exactly say, hey, this is how you put it in. Second graph to look at the table. This is all you had to do. There's negative 5, negative 9. Yes. When x is negative 5, y is negative 9 in the function. N. Okay. Negative, let's go 3, negative 4. Alright, 3, negative 4. Where are you at, table? Oh no. You could have said, no. You could have said, when x is 3, y is supposed to be 11. Explained. Okay. How could I have done... Okay. What part of the test could you have also thought about? Boom, right there. 16. It's the exact same thing. You could have plugged the x in, see if it gave you that y. I don't know if some of y'all made that connection. Let's do it again. Alright, without the calculator. Here we are. Let's see what y is supposed to be. Here we go. 5 halves. 1 plus 3. Minus 4. So I'm putting 1 in for x. 5 halves times. That's a 1. 4 over 1. Minus 4. 20 over 2 minus 4. 10 minus 4 is 6. N. Okay. Ooh, there it was on the table. Okay. Let's go up. Negative 1, 1. No. Okay, negative 1, 1's on there. How can I prove it? Plug that in for x. Figure it out. 5 over 2 times 2 over 1 minus 4, 10 over 2 minus 4, 5 minus 4, 1. You could have done it that way. N. All right, let's hope one. Nope. Okay. I'm getting tired. All right. So, Mr. Calculator. Okay, here we go. Here we go. Which of the following is equivalent to that? Okay, let's do this. I got to distribute that negative 3/4 across. Let me do a little zoom in. Okay, I'm doing a little zoom in action. Okay, let's go. I could use my calculator, negative 3, alpha y equals, enter 4, scoot to the right, times negative 8. 6. Okay, one last step. 6 plus 3 is 9. Okay, so which one of these is equivalent down here? Well, one's screaming at me here. That was the exact same line. Oh, look at this one. Nope. B is 0, negative 3, not 0, 9. Okay. Is there any more we can cross out? Ooh, minus 9, not the same thing. So that's not the same. Okay, we got a couple more up here. All right, let's simplify this one. Distribute. All right, no calculator this time. We're doing, I'll put a plus there just to, negative 3/4 times 4 over 1. Okay, you could have said not same line. It didn't simplify. It's got a different y-intercept. Okay, let's go calculator on this simplification. I'm going to press second enter. Go back, change that to a 4. I'm going to delete that negative. It stores your last, the way you can press second enter, it stores your last 10 calculations. Negative 3 times negative 4 is 12. 4 times 1 is 4. It's the problem I've been looking for. Done.